Welcome to the today's video lecture series. In last class, we discussed about the DC motor constructional parts. In today's class, we are going to see about the DC motor operation, which comes under the course outcome 2 to exemplify the electric propulsion system and motor controlling techniques, under which the learning outcome 1 is to discuss about the electric propulsion system, under which the specific outcome 2 is to explain the construction and working principle of the DC motor. So the content of the today's presentation has been associated with the DC motor working operation and Fleming's left hand rule. This DC motor working operation is based upon the only the Fleming's left hand rule. Let us go into the topic now. So according to the Fleming's left hand rule, if the thumb finger, middle finger and the index finger or the forefinger of the left hand are mutually perpendicular to each other, then the forefinger or the index finger represents about the direction of the magnetic field. Then the middle finger represents about the direction of the current flowing through the conductor, and the thumb finger shows about the direction of the force acting upon the conductor. So hence this Fleming's left hand rule has been used to determine the direction of the force acting upon the armature conductor which is being placed in the magnetic field. Next, so with help of this diagram, the Fleming's left hand rule can be stated that if the forefinger, thumb finger and middle finger are mutually perpendicular to each other, then the forefinger or index finger represents about the magnetic field. Then the middle finger represents about the direction of the current flowing through the conductor, and the thumb finger represents about the direction of the force acting upon the conductor. So by which here we can say that the Fleming's left hand rule is used to determine about the direction of the force acting upon the conductor inside the magnetic field. Next, so motor principle, we know that an electric motor is a machine that converts an DC electrical power into an mechanical power which is known as a direct current motor. So the motor working principle is based on the whenever the current carrying conductor, that is an armature conductor, is placed inside this magnetic field, then this armature conductor experiences a mechanical force or a torque. So this is said to be the principle of operation of the DC motor. So the direction of the force developed on the armature conductor is given by means of the Fleming's left hand rule. The magnitude of the force acting upon the armature conductor is equal to the BIL newtons, where B is said to be the magnetic field and I is said to be the current flowing through the conductor, L is said to be the length of the conductor. According to the Fleming's left hand rule, when the current flowing through the armature conductor which is being placed in the magnetic field, then the magnetic force produces on the conductor. That means the torque is developed on the conductor, due to which the armature conductor is rotating inside the magnetic field. So this direction of the force developed on the armature conductor is always perpendicular to the length of the wire or length of the armature conductor and the magnetic field developed on the armature conductor. Next, so with help of this diagram, we can explain about the DC motor principle. That means whenever the current carrying conductor is placed inside the magnetic field, then this current carrying conductor experiences a mechanical force or a torque. So due to that, what happens whenever the current carrying conductor placed inside the magnetic field, so there is a flux, magnetic flux produced by means of the current carrying armature conductor, and there is also a magnetic flux due to the field coils. So both flux, that means the magnetic flux due to the field coils and the magnetic flux due to the armature conductor will get interact each other, due to which the mechanical force or a torque has been experienced on this armature conductor, which allows the conductor to rotate inside the magnetic field. So the magnitude of the force developed on the armature conductor F is equal to BIL, where B is said to be the magnetic field, I is said to be the current flowing through the conductor, and L is said to be the length of the conductor. So here the length of the conductor and the magnetic field both are perpendicular to each other. This force acts on the conductor will always perpendicular to the current flowing through the conductor and the magnetic field developed on the conductor. So this is what the concept or the working principle of the DC motors. I hope that you would be understood about the working principle or a working operation of the DC motor. Thank you.